Hi, my name is David Johnson. I'm a senior software engineer and researcher at the University of Utah. And I'm going to talk about and demonstrate some work that we did with Keysight Technologies to integrate Keysight's RICtest software into Powder's Lab as a Service automation framework as we pursue better on-demand ORAN test automation. This figure contextualizes the test workflows that we'll be demonstrating within the ORAN architecture. The system under test is an updated version of the ONF SD-RAN RIC and its associated KPI Mon xApp. And the software that we'll use to test this RIC is Keysight Technologies RICtest software, which is designed to test the near real-time RIC and xApps and RApps by emulating the E2 and O1 interfaces of RAN nodes, such as ODUs, OCUs, GNodeBs, and so on. RICtest can test both aspects of the RIC and xApps and RApps at scale, and it provides a highly configurable traffic model that provides KPIs over the E2 via service models. This allows users to test both xApps and RApps. RICtest is virtualized and can run in the cloud and provides a RESTful API that we're going to use to automate testing. This slide shows, at a very high level, the big functional components of our test workflows. At the top, we have the Powder Lab as a Service automation framework deployed in a virtual machine that's going to execute our test workflows using RICtest to execute the tests, and again, the ONF SD-RAN RIC is the system under test. In this scenario, we have an existing experiment running the automation framework. We have an existing experiment running RICtest, and the workflow is going to stand up automatically the missing piece, the ONF RIC from bare metal. It's going to deploy Kubernetes and the SD-RAN RIC. It's going to connect those via private shared VLAN so that the test can be run, and it's going to repeat and iterate over this test workflow across a parameter space. We're going to explore two different Kubernetes configurations running different network plugins, as we've seen some variability with how those work on SCTP connections in the past. And then we'll explore two simple RICtest scenarios. After that, the workflow will terminate the ORAN experiment that it stood up, and it will persist the results in our test case management system. I've dropped some links to Keysight's RICtest product and to the Powder platform, and I'd encourage you to visit those links and learn more, and contact us if you're interested in using any of this software or the automation pieces. But with that, I'm going to jump straight into the demo. I'm already logged into the Powder web UI, and I'm looking at a list of the experiments that I have running in our integration project with Keysight Technologies. A Powder project is both a container of users who have membership and permissions to allocate resources in that project, and the resource allocations themselves, which are experiments. Experiments are instantiated from profiles. Profiles are recipes that list resource requirements and configurations from bare metal hardware types through network configuration and software that's being instantiated on those resources, including user-supplied scripts that provide additional runtime configuration once the experiment is stood up by the platform's orchestrator. I have a number of experiments here. One of them is an instantiation of Powder's Lab as a Service workflow automation components. This is a simple one-node experiment that is connected to a shared VLAN, allowing it to connect to other experiments that are instantiated later. This profile provides a couple of links to other key components involved in this demonstration, which is the workflow engine itself and the test case management system, both of which provide separate web UIs, and we've configured them with per experiment random passwords. So I'm already logged into the workflow engine's web UI, and I can see in the past that I have already run a number of workflows as I've been standing up this demonstration as we've been conducting our integration activities with Keysight. So this is the history page that shows the workflows and shows the actions that I've run in the past. Before I dive too deep into the details of the workflows and the workflow engine, I'm actually going to kick off one of those workflows. So I'm going to do that by pushing an update to the Helm chart repository containing our updated version of SD-RAN. Now that I've done that, that's going to update the Helm chart index file. And StackStorm is well set up to trigger its workflows based on external event inputs. So I have a sensor that I wrote that listens to our GitLab server and watches for chart updates. And that's running. And it looks like it's already picked up an update that from my Helm chart push. And associated with, so once the sensor fires, it creates this trigger. And there's a rule within StackStorm that I wrote that is listening for this trigger to fire. And rules can match specific values. In this case, we're just taking any invocation of this trigger, and we're using it to launch the test workflow that is the subject of this demonstration. There are a number of parameter values. The double-braced values are defaults from the configuration underlying StackStorm. But you can see that we're going to be iterating over parameter spaces, including Kubernetes overrides, SD-RAN overrides, and the RICtest configurations. This creates a parameter space. So if I go back to the workflow history, I can see that I've got a new workflow that's executing, and it's already started to execute some of the actions in that workflow. In StackStorm, the fundamental unit of automation is an action. Actions can be things like a remote command invocation on a Linux system via SSH, or they can invoke actions supplied by more complicated integration packs. Now, I've written a number of integration packs that are the basis of this integration, and one of those is creating an ORAN experiment using the Powder Remote API right now. So if I go back to the Powder web interface, if I refresh this page, I'll see that ORAN experiment being instantiated. It's got a slightly randomized name. This is a one-node experiment that has a placeholder that's ready to connect to a shared VLAN, and we're going to connect it to RICtest. What I mean to say is the workflow is going to invoke the Powder Remote APIs to connect it to RICtest once it's been stood up. So all Powder resources are remotely accessible. I could click on this node and open a web console. I could look at the serial console, look at the console logs, power cycle it, reboot it, reload it from scratch from a base disk image, and so on and so forth. This profile provides access to the Kubernetes dashboard once Kubernetes is stood up inside of this experiment, and it gives instructions on how to access that. This is a fully automated run, so we're not going to look at that, but this is the experiment that the remote API is standing up right now. It is an Ansible-based profile, and so there's a large amount of Ansible automation that allows custom deploys of Kubernetes and the SD-RAN RIC based on overrides that are sent to those Ansible configuration management playbooks and rules. I mentioned that we'd written a number of integrations for StackStorm, and those integrations are encapsulated in integration packs. So I can go and look at the packs that I have installed in my Workflow Engine instance. Here's the Powder integration pack, and this provides a number of actions that can be used to launch and connect experiments together and terminate them when completed. We wrote, of course, a Keysight RICtest plugin that exposes the RICtest remote API within StackStorm, allowing workflows to configure and start and stop tests and collect their outputs and KPIs. We wrote an integration to the Kiwi test case management software that allows us to configure tests and upload test outputs and status into the test case management system. And finally, we have a different kind of pack, which is a workflow pack. Roughly speaking, StackStorm packs come in two flavors. One is an integration pack, which provides actions that allow further integration with other systems. And then workflow packs, which primarily consume the actions provided by other packs and utilize them and orchestrate them in more powerful, more complicated workflows. And that's what the ORAN pack does. And it's providing the test workflow that we're using in this demonstration that's running over here in the History tab. So let's check in on that and see how it's going. Looks like the experiment has been stood up. So if we go back here, yep, there's a little checkbox indicating that the startup scripts that are installing Ansible and preparing the node for standing up Kubernetes have been run. So if I go back to the workflow and kind of try to get StackStorm to show me the latest actions that have been fired and are being fired as part of the workflow, we can see that the experiments have been connected together via shared VLAN, and we're now starting the first iteration across the parameter space that was set up by this earlier action up here that's going to run 4 times in a loop across the different parameterizations of Kubernetes and RICtest scenarios. If I dive into that, I can see that the first step is a sub-workflow that populates the test case management system with test metadata. So we're pushing the system under test product information into the test case management system. We're creating a test plan consisting of individual test cases. These are fairly straightforward E2 procedural related test cases. Were all E2 setup messages successful? Did all subscriptions complete successfully? Were all indications sent? Indications sent being reported by RICtest at the end of the scenario, and then confirmed by seeing that all were received by the SD-RAN KPI-mon xApp. So we're populating the test case with the test case management system with all of those items, and then setting up executions where we will log the pass-fail results of those test cases and upload information that we obtain from RICtest over its remote API, things like packet logs and raw KPIs and CSV files. So if we scroll down, now that we've populated the test case management system, we're also starting to deploy Kubernetes within the ORAN experiment that we stood up. The first run of this is deploying Kubernetes with the Calico network plugin. Subsequent runs will use the Flannel network plugin. I'm actually going to pause the recording here while the Kubernetes sets up. It takes it approximately 10 to 13 minutes to initially deploy because it's pulling down a lot of Docker images and doing a lot of initial configuration. Future runs won't take quite as long. We'll check back with it in a minute. Okay, at this point, both Kubernetes and the SD-RAN RIC have been deployed, and the next step in the workflow is to actually run RICtest. So let's go over to the RICtest web UI, and we can see that we've populated a configuration and we're running a test. So we can observe that test running inside of RICtest, and I'm going to go straight to the live statistics view of the test first while the test is executing. We can see some traffic statistics at the top, and immediately after that, and specifically of interest for this test, are the E2 procedural statistics. We can see that we've got 4 total SCTP connections. That's because we have 2 emulated RAN nodes in this test scenario, and the SD-RAN RIC is creating 2 SCTP connections to each of them. We're also getting some feedback from 2 successful E2 setup procedures, 2 successful E2 subscription procedures, and 2 successful E2 connection update procedures from the new E2AP v2 standard. If we scroll down more, we have a log of other procedures, total E2 messages, as well as the total number of E2 indications that have been sent. And this is a KPI-mon xApp case where KPI-mon is subscribing to KPMv2 in the emulated RAN nodes. There are some other statistics that we're not making use of in this test that RICtest is showing us. including available PRBs, PRB utilization from the emulated traffic model, and the total downlink and uplink throughput. So the test scenario has concluded, and the UEs are no longer connected to the emulated RAN nodes. And while we're waiting for the workflow to recognize that the test is over and to actually stop the test, we can go back and look at the scenario overview page within RICtest. And we can see, as I said, this is a simple test scenario where we have one eNode B and one gNode B emulated, and they're connected to the near real-time RIC that was stood up automatically by the test workflow. There are 2 timelines, each with 50 UEs. And we could have also allocated or asked RICtest to emulate ODUs and OCUs in different configurations. If we drill down into some of these properties, we can change additional information about the eNode B and gNode B. We can configure their E2 interfaces and things like that. Looks like the test is stopped, so if I go back to the test dashboard, I can see that I still have my test session, and eventually I'll be able to browse the results within RICtest. If I want to reinstantiate those previously run tests, I can do that. You see that my test session has vanished from my little test sessions menu up here, and that's because the workflow is cleaning up after itself. But the results are still available and persisted in the results menu, so if I wanted to go back and look at that test again, just click on it, select it, and load it back up. And this would allow me to rerun the test and to access the statistics that were run during the test, so I can see the same view that was accumulating in the live visualizations after the fact if I want to drill back down. And through other menus, I can access the outputs of the test in CSV and log file forms. Going back to the executing workflow, we can see that basically what happened, what we were watching inside of the RICtest UI was the workflow using the StackStorm integration pack that I wrote to talk to the RICtest remote API to create the configuration based on the overrides we have in this test workflow scenario. Create a test session, start it, wait for the test to finish, stop the test, collect the KPIs in CSV form, and collect logs, including E2 packet logs. After that, the session was cleaned up, and we're preparing for the next test. The workflow then proceeded to collect corroborating metrics from SDRAN, and in parallel started attaching the raw data obtained from the RICtest remote API into the test case management system. So you can see a lot of invocations of the attached files remote API for the test case management system. Finally, once we've obtained all of the metrics from SDRAN, then we're starting to update the individual test case execution bits in the test case management system, and they're all being flagged as passed. And so it looks like that's largely completed. So this is the end of the workflow iteration, so we'll collapse that. And shortly thereafter, the next iteration over the next parameter space will occur. But let's go and look at the test case management software and reload this test matrix. We can see that the most recent test run 75, has all of its executions flagged as passed. So we can go and look at the details of that execution. We can see a list of the test cases that were being executed. We can see all of the attachments that were just uploaded by the test workflow, all of the CSV files containing the KPIs from RICtest, as well as JSON files that describe in exact repeatable detail the RICtest scenarios with all of their configuration, and a E2 packet capture file. If I go back to the workflow, as I said, we've begun the next iteration across the parameter space of RICtest, and once again, we are setting up the test case management software with all of the cases and runs that we're going to populate. Redeploying Kubernetes was a no-op because we're using the same configuration. So the only interesting part here is that we were redeploying SD-RAN with a new configuration, and then we're running RICtest again. So if we go back to the RICtest UI, we see that there's another test running. This one is using a slightly larger scenario. Obviously, we're not exercising the full scale of RICtest, but we have 5 eNodeBs and 5 gNodeBs this time, and a total of 400 UEs. And again, we can watch the live statistics come in as RICtest is testing the SD-RAN RIC. This time we have basically higher numbers of E2 statistics. We still have successful subscriptions, and we're seeing a higher rate of indications transmitting, of course. So really that concludes this demo. This workflow is going to iterate a number of times, and as I said, the end of the workflow, and we can look at a prior execution to see how it ends, but it ends by terminating the ORAN experiment inside of Powder. But at this point, the test outputs have been captured in the test case management system for later review. Thank you. That concludes this demonstration. Again, please do visit these links and contact us if you are interested in utilizing any of this test software or the automation features within Powder. Thank you.